Hello, this video is to show how to use G matrix 7. First I start a fresh new. Then the first thing is to add node. I can press F2 or press here on add a node. I can put the coordinates here, example like 0. Press enter and the node has been created. As well, you can see the table here that I can edit also directly. So I need to add member 4, member 8, then I can window select, node copy. I have del dx, dy, dz, so I need to put a height of 1 meter. Now this node has been created. Add a member from this point to that point. Just an example for usage. Second thing, I need to add, press escape. I need to add support, node properties. I will lock fx, fy, fz and keep mz. Right click, show supports. Right click, show labels. Right click, show sections, so I can see the section here that I have created. In case I need to know what are the sections that has been entered by default, it's a tapered section, steel, tapered, so on and on, the start depth, the end depth. Save it. The second part is that definitely I need to add a load, so all by right click. First, before that, I need to check the material properties. Material number 1, I'm gonna call it steel. Young's modulus, Fy, F ultimate, Poisson's ratio, which is 0.3 for the steel. Temperature, coefficient, density of steel in kilograms per cubic meters, and the bolt according to ASTM. Second point, I have to create a load case. So the first load case, I'm gonna call it dead load. Second one, live load. I'm gonna remove now the sections, so I will select this and this members. First we select, right click, load case. I'm gonna add a uniform load, load screen location that I have selected, or I can immediately put the member number here. So I'm gonna put, this is dead load, replace member 8 and 9 that we can see here on the screen has been added to our selection. Global load -2, and the second thing is a live load. I'm gonna add a live load, also selection -4. Now, how to add the load combination? Also right click, load combinations. So automatically I have to call it, let's say comb1. SW is a self weight which is always directed against the -y. I have to add 1, the amplification factor, dead load amplification factor 1, live load amplification factor 1. What else do I need? Analysis and design. So you can choose between linear, second order, 3D, 7D, direct analysis method, so I'm going to use now this default, and these are the code that you can use for your design checking. Run. Please provide a name. Okay, sir. So first I need to save the file because I forgot to save it. I go to project, presentation, or samples. Sample 1. And the file will be saved as .gm7. I can run it now, and I can see graphically the stress ratios for every member. If I want to see the value, I can see the value, so I'm going to reduce it a little bit, remove members and remove nodes. So you can see the stress ratios here in color, as well the stress ratio color range is very well shown here. So stress ratio, everything is passing. If in case I want to check the deflection of that structure, I can see it in number, or I can press Ctrl and turn the wheel, and the deflection will be amplified, so I can see the movement. In case I want to see the moment deflection, the moment diagram, I mean. So this is a moment diagram. MZ, MY, torsion, shear, same thing. Control and wheel, axial load. So this is the axial load. Those are the values, I can see them. MY is 0 definitively, MZ, and deflection. The deflection result is in millimeter. Okay, so that's an example number 1.